All right, everything seems to be fine again on my end, so I think we are live. So, welcome to my presentation about DevOps with Azure Data Factory and Databricks. The title is a bit different than on the description, but it's the same presentation anyway. And I'm doing this presentation because we have been doing a certain project that uses both of these resources, and I've had to learn how this actually works. So let's get started here. First of all, who am I? Well, I am Pasi Huuhka. I work as a DevOps architect at Azure, and I've been doing Azure stuff since 2014. And during that time, I've helped to develop and automate solutions and applications for different sized companies, at least 20 of them, probably even 30 right now. You can find me on Twitter at Dr. Bushitop, and I also write a blog every week, also at huuhka.net. And as you can see on the screen, I have some Azure certifications, and I'm also an MCT, and I'm also an active member and organizer on the Finland Azure user group. So check that link out there as well. A little bit about Azure then. We have been doing Azure PaaS since 2011, 100%. And we have a lot of experienced people in the company right now and a couple of Azure MVPs as well. We're also a Microsoft Gold partner in several different fields, and our kind of motto is to be the best Azure PaaS house globally. And this year we finally expanded to Belgium as well. So you might call us an international company now. About the session, well, you will learn what Azure Data Factory version 2 actually is. How do you deploy it? What are the development flow options? And some other magic tricks that I've learned. And the same thing pretty much for Databricks, but most of this presentation will focus on Data Factory version 2. And then we will walk through a use case of and the DevOps flow of the whole solution. I'm just going to check that everything is correct on the stream here. Then we can continue. Yes, looks correct. All right. So a little bit about the services first. So Azure Data Factory version 2. As you might imagine, there has been a version 1 as well, but I don't have much experience in using that. But in any case, Azure Data Factory version 2 is a cloud-based data integration service that allows you to orchestrate and automate data movement and transformation as well. And here you have the most lowest resolution image possible, but basically it handles ingestion of data, controls the flow with kind of code-free data pipelines, and has the ability to schedule things and monitor them and so on. And from the top-down view, you have the ability to copy data from service to service with connect and collect. You have the ability to transform and enrich the data. And here's where kind of the low code to no code options come in. And it also allows you to orchestrate the enrichment in other services. Then you can do some publishing, which means that there is a full support of CI/CD tooling with GitHub and Azure DevOps repositories, for example. And lastly, there's a capability to monitor all of this. So Azure Monitor logs, There's a monitoring API that you can call, and you have PowerShell SDKs also. The components of a data factory are basically a link service, and these can be something that store data or handle data, like the name says, a service that is linked to the data factory. Then you have a data set, which, as the name says, is just a set of data, and the data is coming from some linked service. Then you have activities, which basically do something with the data. And when you get a lot of these activities, you get a pipeline. So a pipeline is kind of a combination of multiple activities that actually move the data and do something with it. Pipelines, of course, have triggers, so you can set when they run. And when this is complete, you have the data moving to the dataset or from the dataset somewhere else. Data Factory also supports parameters. There are different ways of doing integration runtimes, so you could even run this on your on-premises VMs. So I don't have much experience on doing that. And then there's a way to control the flow of the data in general. And here's a bit of kind of a dependency graph on all of these parts here. So first of all, it's maybe easiest to look at from the right first. So a pipeline, you can schedule them, and it is a logical grouping of activities here. And activities run on linked services, so Hadoop clusters, Databricks, SQL servers, and so on. And the activities can consume a dataset or produce one. And a dataset is basically a representation of data stored in one of these linked services. Then a little bit about Databricks. So as seen here, Azure Databricks is basically a collaborative Apache Spark analytics platform. And it's kind of designed with Spark, and it's integrated to Azure with one-click setup, streamlined workflows, and interactive workspace. And it supports kind of these Python notebooks, for example, which allows for collaboration there. And for big data pipelines, you usually use Data Factory to ingest the data, then do something to the data with Databricks, and then lastly store the data in Azure Storage or other data services like SQL databases or warehouses. And in the whole Azure data story, you can see that Data Factory is kind of this overhanging service which handles orchestration, and then Databricks is here in the prep and train placing, basically, in the middle of all of it. And some benefits from using Azure Databricks: well, increased productivity. This comes from the notebook environments. Then Azure is of course safer than your on-premise solutions. And it allows you to scale without limits. Though, of course, there is an asterisk behind this, because as we have seen in the COVID times now, cloud scaling is not quite limitless. Sometimes it might be tough to get even one VM that you need. And some added benefits with Databricks are, of course, role-based access control. Auto-scaling is quite easy. You get the collaboration tooling with notebooks, and you can schedule jobs pretty easily. And the scenario for our project, in this case, is Seure. So Seure is basically a workforce leasing company that provides workforce for the greater Helsinki area. And they are providing people to hospitals and public kind of kindergartens and so on. And our solution here is kind of a mobile application for their workers. And also this project specifically allows us to use Data Factory and Databricks here to get data from their employees who are free, and also what kind of locations need employees at the moment. So we can do some placement data there, or placement processes there. So when the people who are actually doing the placement, they're manually right now, often they needed to spend hours every day to find a suitable person to go to a suitable place, but now they have the placement information kind of ready, so it saves them a lot of time, because we have already done the checks that this hospital needs a person working for them. They need to have this specific certification to be actually eligible to be working there. So those kinds of issues. And in this case, as shown here, we are basically getting the data with Data Factory, transforming it with Databricks, and then storing it in our SQL database. Our requirements for this solution were that basically we want to do everything in ARM templates with complete mode, which means that anything that is not in ARM templates gets deleted from the resource group. This way we have complete control of the environment with the ARM templates. All of our code also needed to be version controlled. And with Data Factory, we wanted to do unit testing, or at least have the capability to do those unit tests. And with Databricks, we have a custom library that we are using, and we have, of course, notebooks in our repository that need to be deployed to Databricks. First up, let's take a look at ADF development flow. This is a bit complicated, and Microsoft provides an example of how to do this. And currently I think that is the best way to do it, what Microsoft suggests. But I also do have a simpler solution that you might want to use for some development work. But basically, first of all, we want to have an ADF instance per environment. So one for development, one for test, and so on. Development is always done in the developer portal in Azure Data Factory, which I will show you soon. The development can be done with either direct deployment or with Git integration, but let's be real here, Git integration is the way to go. I should probably even delete the direct deployment capability here. And then in the background, Azure Data Factory generates ARM templates automatically behind the scenes. And these will get placed in a specific branch in your repository. And those kind of hold all the configurations that people do inside the Data Factory, so to say. And those will then get deployed to test and production. And to make this perhaps a bit clearer, Microsoft provides this kind of process image. So first of all, I will show this completely in the portal itself soon. But basically, first of all, when the developer comes in the ADF portal, they create their own development branch here. When they are done, they create a pull request to the collaboration branch. By default, that is the master branch. Then from the master branch in the ADF portal, they can click publish. And I would say that at this point, the actual logic gets moved to the development Data Factory. And at this point, I think the ARM templates are actually created as well, even though the image does say that ARM templates are created at this point. But if you publish here and your ARM templates fail, or they have some problems, it will not even the code go to development. So the main thing to understand here is that as there are two modes in Azure Data Factory, the Git integration mode and the Azure Data Factory mode itself. The Git integration mode, which I will show you soon, will not be the state at which the data factory is in. Only after you hit publish will the state change in the data factory. But yeah, at that point, we then have in our ADF publish branch our ARM templates, which hold kind of the complete contents of your development data factory. Then we check the ADF publish branch with our release pipelines and see if that has been updated. Then we can just build a new package from it and perhaps release that package to ADF test environment and production environment. And to show you this a bit clearer, I have a demo, because this is probably the most complicated part of the whole thing. So here we are in Azure. And if we click here, we go to Data Factory. And as you can see, we are in the development portal. And once you come in, we can see that, first of all, our repository has been set. This is done in ARM templates. I will show you that soon. And when we come in to the author page here, we have the two modes that I was talking about. Azure DevOps Git, which in this case is what is in our Git repository, and the data factory mode. What is the actual state of the data factory at this point? So we can see here clearly that we have Git enabled in our data factory, so publishing in data factory mode is actually disabled. So they kind of force you to go through the Git integration publish process that I just showed you if you want to update this. But how this would work is that I have pipeline 1, I have wait task here, so this really does nothing. But I would then go here to the Git version. I would create my own branch, and once I did changes, create a pull request to the master branch. I'm just going to do a change here in the master, so rename this to wait 2. I would save this, and then I could publish. It says that my pipeline 1 has been edited. And once I click publish here, I get the ARM templates pushed to a certain repository or a certain branch. And also when we go in here to the data factory, we see that now our name here has changed. And here we can see that we are generating the ARM templates as well and saving them in Git. And how this actually works in our release. Let's go back here. We can see that our ADF CI has been triggered as we have new things in the pipeline from the ADF publish branch. We go to edit this, so we can see that this doesn't really do anything else here than just publish some pipeline artifacts for us that we will use in our releases later on. And here is kind of the location where you could do your unit testing against your development data factory. Because at this point, the development data factory is in the state that you want it to be. You can test against it and then only publish the artifact if your tests pass. The tricky thing here is that how do you actually test the ADF? I don't really have an answer for you right now, but you could run some PowerShell commands. But the question is, what do you actually want to test? You could perhaps see that, do you have a certain number of pipelines that are named this way or something like that, but it entirely depends on your use case in this case. And once the packages have been found or generated here, we can go to the ARM templates in this case. So what I want to show you here is that because we are using complete mode with ARM templates, checking on the screen here quickly. Yeah, still seems correct. So because we are working with complete mode in the ARM templates, we basically have to use linked templates in this case. And that is kind of the default way I often do on templates anyway. So I have just the URLs of my templates specified here in the ARM template. And then I have these deployment resources. So first of all, I deploy my databases. Then I deploy base things. So let's take a look at that quickly. The important thing here is that we have the Data Factory resource. And as you can see, this is very simple. The only thing that comes to mind here is that we set up the properties like this. So if our environment is development, then we set up our factory configuration. Otherwise, we don't set up any properties because all of the contents of the data factory come from the auto-generated ARM pipelines or ARM templates. But if this is the dev, we do need to set up the Git integration. And the Git integration is set up here. So factory configuration. And there's just this repo configuration, my VSTS account name, repository name, collaboration branch, and so on. Quite simple setup. Now, if this was a test deployment or a production deployment, we still need to do the auto-generated part then. So we have a condition here. If it is not development, the environment, then we deploy this. And we have the auto-generated ARM files here. And we know what the URI is because we are uploading these to a certain storage account ourselves. I will show it to you soon. And the important part here is that for the factory auto-generated ARM templates, we need to give in some parameters because some things will change between your environments. For example, the data factory name, that will need to be given in. And then the name of the key vault. And how do you actually know what these need to be? Well, the easy thing is to look at the auto-generated templates. So I have them here, but you can find them from this button as well. Or just look at the ADF publish branch that you have. But here's the export ARM button as well. So the main thing that you need to look at is the ARM underscore template here. And in my template, I can see that here are the parameters that I have. And this is, for example, a pointer to a key vault secret. So is this, but the key vault name and the data factory name I'm giving in here. And the last thing I have in my ARM templates is just a key vault. And the interesting part maybe here is just using a managed identity of the data factory here by referencing it to the ARM APIs. Quite simple. Then to go back to the actual release of our ARM templates and everything else in this case. So let's take a look at the test, because that's the interesting one. So first of all, not really important, but we are cleaning some resource group histories. There's a limit on how many deployments you can have until everything breaks. Then we get a previous ARM output, previous successful one, if you have it. This isn't really needed, and obviously doesn't work on the first try. But what I basically do here is that in my ARM templates, I often have naming conventions here. So this is my source of truth for this. So I just output the names here. So SQL server name, Snowflake function name, and so on, whatever I need. So I can just later on in my ARM templates or in my release pipelines use those same things as variables here after I have run this script, which kind of gets those values as variables in my pipeline. But yeah, basically first, as we are using linked templates, we need to move them to a storage account. And here I am moving all the others except the auto-generated ones, and then just the auto-generated ones after that. And why I'm doing this is because linked templates kind of need the sub-templates to be accessible by Azure via the internet. And this is kind of done with getting the container URI here and the SAS token here in this task. So I basically have a SAS token behind which everything is in the same storage account. Then I just deploy my ARM templates. I'm giving in the template link and then parameters link, and I use the variables here as shown. And before I do this, I of course, well, not of course, but apparently need to stop the ADF triggers. So if I have a pipeline which triggers at every now and then, I need to stop it first before I deploy it, because it seems to give out an error. If it is enabled, ARM templates might fail. So I stop them. And this is just a very simple script that I have here. Let me show you that quickly. So here basically I just do a trigger, first get all the triggers here, and then just loop through them and stop them individually. Well, this starts them, but the stop script is very similar. And after I have deployed my linked ARM templates, I start the triggers again. This is a bit questionable in the sense that if you are doing deployments when the trigger should run, of course, if it is stopped at that point, it might not run. So you kind of need to think about that a little bit when you're doing this. But I have not yet found any other way to really do this part. But yeah, all of our configuration is via the ARM templates. And if you take a look at the test environment that I have here, that's wrong. Yeah. We can see that as we do not set any Git integration, we don't have that button here. And we also don't have anything Git integration related here, but we do have our pipelines here. I have not run yet the deployment here, so this name has not changed, but it will on the next deployment. So back to the demo then, or the presentation. So there is a simplified alternative to this. As you can see, that was pretty complicated. We have one ADF instance for all environments, so test, dev, and prod. Publish is done from Git collaboration branch, as before. And this is simple to understand, simple to do. Person goes in, clicks publish, everything goes to production kind of directly. But the cons of this are that there's really no tracking of changes to production, so I can't really recommend this, but it's doable and it requires manual action every time that you need to do a development or deployment. So I think those cons kind of are so big that you probably don't want to use this. And it turns out that the complete ARM deployment does not actually delete the ADF contents, which is a bit weird. So that kind of makes this work though. But then the Databricks part. It's actually kind of similar. Databricks workspace, one instance per environment as before. Development is also done in the Databricks portal. There's a Git integration, but I actually have not tested this, but I think it might actually only work for the same tenant Azure DevOps. And the notebook and the custom library deployments go through CI/CD pipelines. And the pipeline structure for Databricks is basically simple. So we have a repository, we have our build, we get the source, build SQL Databricks libraries, ARM templates, package, version, and publish. Then we go to a release pipeline. We deploy to dev automatically, but currently we have a test deployment with a manual trigger. Of course, that could be done automatically as well. Let's say every time the ADF publish branch completes, for example. And then there are environments after that. So let's take a look at the demo here. So I just have a Databricks environment here, and you can just go to it from the launch workspace button. We have our home, and I have 2 notebooks on my user here at the moment. And as you can see, this is very high-tech code, but the important thing is here that the Git is synced. So as you can see, I have linked this to a repository, but I have not yet found out a way to do this very automatically. So a developer could come in to the portal here, create a new notebook like this test here, but then they would need to link the Git themselves from this button. But yeah, once they create their changes here, they could then do a pull request to the master branch, which would then move these notebooks further. I think there was at least, yeah, here's the branch selection as well. And then let's see what else did we have. Well, the release. How do we actually set this up? So let's start with the ARM templates. So Databricks behind the scenes uses a separate resource group where it will deploy all its VMs and whatever it uses on the back end to actually do the job. So I just set it up here. And that's kind of the only thing I need to set up. Give it a name of a resource group. It will automatically create the resource group and also delete it after you delete the workspace. And then you can set a tier as well. And this at least affects on what kind of secrets can you store on the Databricks environment. But that's kind of only sets up the resource in Azure, but doesn't do any configuration in it. And that is where kind of our release pipeline comes in. So first of all, we get the ARM outputs from our ARM template deployment. We also get key vault secrets as variables. And as you can see, I can use, this is an output from our ARM pipeline or ARM template. We get them all here, so we can use them later on in our scripts. So how our setup kind of works is we have a script that does all the setup for Databricks. And this is basically calling the REST APIs of Azure Databricks. And let me find the actual script here for you. So this ended up being maybe a bit more complicated than I would have liked. But currently there is a pre-made task for Azure Databricks and some PowerShell commands that you could use. But they are made by a third-party company, and I wanted to learn how this actually works behind it. So I ended up creating the REST calls myself. So first of all, I have a function which just does some retrying on REST calls if needed. Then what I need to do is get a workspace ID using Azure CLI. So I have a Databricks workspace that I'm getting the ID for, and then I get the location from it, and then I get a token for the global Databricks application. This ID is the same for all environments, but this is needed to be able to call the REST APIs. And then I get the token for the Azure Management API using get access token here as well for the management.core.windows.net. Then I set up these tokens as my headers and also the base URI to which to use to call the REST APIs from. Then first of all, I list my tokens that have been created before. So these are kind of personal access tokens. We currently have it so that this example is 10, but you could have 2 tokens. That should be more than enough. So basically there's just a limit of 600 tokens, I think, that can be there. So I just do the cleanup here instantly to make sure we don't get into a situation where something fails because of that. Then we call the API here with my caller function. We get the tokens from it, and if there are more than 10, we delete the tokens that are inside. Yeah, the token delete. And actually, why we are even doing this is that we need to set up some secrets in our Databricks environment, mainly for our SQL server that the notebook then can use in the Databricks environment. And this should really be done with a key vault, but currently it is not possible to automate the creation of a key vault-backed secret scope in Databricks environment. So currently we are just doing this with the Databricks secrets. And we do need the token here that we are creating afterwards. So just calling a token create endpoint. Because for the secrets to be set, for some reason, the API does not yet support calling them with just the same headers that we used to call the token create endpoint. So we are creating a personal access token and storing it for our future calls, and also in the pipeline here using the set variable Azure DevOps echo. Then how Databricks environment secrets work is that you need a scope first. So we get a scope list, see if this SQL scope has already been created. And if it has not, we create it with scopes create. And the scope is basically an umbrella for your secrets. Let's say you have a scope named SQL and you have one type of connection string there and another type of connection string. So JDBC and ODBC, for example. Then our scope has been created. And lastly, we just call secrets/put with different bodies. So we have a username, password, connection string that we are pushing there. These could be whatever you want. But these are just taken in the pipeline as parameters to the script. Then we update the personal access token in our key vault, as we have gotten it from the script. Do some database migrations. And then we deploy our egg file, which is kind of this custom library that we have right now. And there is this just Databricks files to DBFS task in Azure DevOps by DataThirst Ltd, which you can install from the marketplace. And here, for the authentication method, we are using the bearer token that we got from the script. And then, lastly, we deploy the notebooks to our environment. And there's really nothing special here. We just put them in the shared/something folder and clean it beforehand. So any files in the target folder get deleted first. And lastly, if you have something else, you of course do that too. And regarding the key vault thing, actually, that I forgot to mention is that for the data factory part, you also need to store all your secrets pretty much in a key vault, because you cannot store secrets in plain text in your repository, of course. And so there is kind of no place where the data factory can store them when you are developing your stuff. So put those in your key vault. So for our solution, I have some improvements that we need to figure out. So first of all, the development flow for Databricks, it is a bit cumbersome because you need to add notebooks manually to Git and so on. And currently, at least at the time when I wrote this, we were doing the solution so that we actually manually moved the notebooks to the repository instead of using the Git integration there. Unit testing should be added, but as I mentioned, what do you actually unit test? I don't have an answer for you right now. And then getting rid of manual steps in deploying the tests and continuous deployment and speed. That's of course one thing that you should aim for always. Our current problem is that we are somewhat bottlenecked by our testing requirement. Then we have also run into some problems. So not all the connectors for ADF are parameterized in the auto-generated ARM templates. There are some steps like function names, for example, that do not get parameterized. So for that, I have just created some PowerShell scripting that looks for this value in the ARM template before we send them to the storage account and changes it based on the previous ARM template deployment outputs. And as mentioned, ADF triggers, they cannot be updated when they are active, so that is why we are stopping them before deploying ARM templates. And troubleshooting can also be an issue, because the error messages from the Git integration are a bit unclear. I will have an example for you in the last slide. And yeah, Databricks does not support key vault-backed secret scopes generated automatically. You need to go to the portal and click manually, which is not really suitable then for if you need to do everything with automation, which we aim for. I don't want to touch a production environment by hand at any point. And lastly, Databricks does not support automated Git integration either, so that's a bit of a hassle. So lastly, we had an example of a troubleshooting issue. So basically, the error message was that the publish branch is out of sync with the collaboration branch, and this is likely due to publishing outside of the Git mode. But as I showed you earlier, it's impossible to publish outside the Git mode. It's disabled. The only way to do this would be that if you have your own ARM templates that deploy the same stuff that the auto-generated ARM would be, and you have edited those manually, then this could happen. But that was not the case for us. Microsoft suggests a solution to remove the Git and add the current branch as new branch, and then create a PR to collaboration branch. There is this button that you can click, basically, which says that generate all the stuff that is in the data factory right now as a new branch in your repository. And then when you do the PR, then everything should be in sync. And this is kind of a nuclear option, but it should work all the time, right? Well, it did not work for us. So I even tried to recreate the whole data factory from scratch, and publish the collaboration branch again. But we ended up in the same issue again, even though there's no possibility of doing that they would be out of sync. But then I thought, how does this ADF actually work? Well, it deploys the ARM templates in the backend. So I looked at the deployment history of the ADF resource group, and I saw these things. And then when looking at the details, I ended up seeing that, hey, there's a invalid reference to a storage account. So there was a storage account key somewhere that was wrong. And after fixing that, everything started working. So if you take a look at the situation being out of sync with the Git integration, that's not really at all the case what was happening here. So the error messaging could perhaps be better, but I'm not sure how it could have known this other than just looking at the deployment histories. And Data Factory is kind of strange in the sense that if you take a look at these, if these would have succeeded, it would delete these deployment histories instantly. So you only see these in the logs when you check when the publish is going on or if they have failed. But there are some takeaways from these experiences. First of all, you should utilize Git integrations whenever possible. You should always use a key vault to protect your secrets, especially in Data Factory. You should use linked ARM templates for deployments. We use them in almost every project now anyway, so they have become quite familiar. And then, if you have problems, try to figure out how does the service actually work under the hood. And that will help you troubleshoot. And lastly, some links. These can be found in the slides later on. So there was a blog post about unit testing for ADF. Then there's a connector secret for Git integration, API reference, and of course my blog. And lastly, this is the important part. If you don't take anything else from this presentation but this, try to remember this, that the master branch is not representative of what's deployed in the Data Factory service, and it must be published manually for the changes to actually move there. Here are the slides. I will paste this link in the YouTube chat. And if you have any questions right now, please write them in the chat, or if there are any, I'll take a look there as well. So let me just paste this link in the chat quickly. This time the chat seems to be quite silent, but I will wait a minute here and then empty call. If you have any questions in the future, you can always find me on Twitter at Dr. Bushitop. And well, thank you for joining the session. And feel free to check out my previous session on the same channel as well. Thank you. Actually, we have one question here. So, how can we connect to any REST API using basic authentication? I don't think that is possible, because when you are using the REST APIs, you need to have the management.azure token. So it kind of uses Azure AD on the backend. So I'm not sure if that's possible. at the moment. All right. Thank you and have a nice weekend also. Oh, it's Thursday. Well, anyway.